All right, welcome back, Pre-Calc. Hopefully all of you had a great Easter weekend. Enjoy some time with your family. So today we have section 9.5, simplifying complex numbers. So without any delay, we'll go ahead and jump right into things here today. So what we're going to do, we're going to add, subtract, multiply, and divide complex numbers. Complex numbers, in case you forgot, those are numbers with I in them. So when we have the square root of -1, that's equal to I squared equal to -1. And so forth, which actually we'll see here on this next slide. So I to the first is just known as the square root of -1, but we'll refer to that as I. So if you ever see the variable I, we refer to it this way, although what it technically equals is the square root of -1. I squared is I times I, and if we take a square root times itself, it's going to equal that number. So if we go to I cubed, that's really I squared times I. So -1 times I, negative I. And I to the fourth is really I squared times I squared, which is -1 times -1, or +1. What happens when we get to I to the fifth, I to the sixth, I to the seventh, I to the 983rd, this pattern continues. So every time we keep going here, for example, I to the fifth, which would be the next one in this sequence, I to the fifth is really the same as I, since it's I to the fourth, which is 1 times I. I to the ninth, that would be I to the fourth squared, which is 1 times I. So all of these multiples, if you keep adding 4 to 1, so 5, 9, 13, 17, 21, they all equal I. Same thing with I squared. If we keep adding 2 to that, I to the sixth, I to the 10th, I to the 12th, so all of those numbers equal -1. If we get down here, let me bump this down for a second. So if we keep going and add 4 to 3, I to the 7th, I to the 11th, I to the 15th, that's -I. And any multiple of 4, I to the 4th, I to the 8th, I to the 12th, I to the 16th, any multiple of 4, that is going to keep equaling 1. And then as soon as we get back to 17, then we're right back to the top again. And it will go I, -I, or excuse me, I, -1, -I, +1. And that keeps repeating. To sum all that up, we put it into what's called the I chart. So this is our basic I chart here, but again, it keeps repeating itself, so you got to remember that. So I to the first is I squared, -1. I cubed is -I, and I to the fourth is 1. You can also use your calculator to help you if you're not sure. For example, if we want to know what I to the 27th is, we really don't want to keep writing this chart out here 5, 6, 7 times. So we can just divide by 4. And your remainder dictates where you're at on the chart. So if you get a remainder of 1 or 0.25 on your calculator, for example 5, if you divided 5 by 4, you'd get 1.25. That's the same as I to the first. So if you get a 0.25 in your decimal, that's I. If you get a remainder of 2 or half, right, 2 out of 4, 0.5, anytime you get a 0.5 with your decimal and you divide by 4, that's I squared or -1. If you get 0.75 with your decimal, then it's -I. And anything that divides evenly by 4 will have no remainder. So for example, if you did I to the 72nd and divide that by 4, you'll get no remainder, and that equals 1. So again, when you divide by 4, if you get a 0.25, that's I. If you get 0.5 at the end of your number, -1. 0.75, like we do here, 6.75, that's I cubed or -I. And no remainder is 1. So that's how we use this I chart that keeps repeating. All right, so the only possible answer is when we get this, there's only 4 possibilities. And again, that's I, -1, -I, or 1. So to get this answer, you can see the answer is I, but how did I get that? I took 53 divided by 4, and I got 13.25. So since I got 0.25, that's remainder of 1, or I. I to the 28th, 4 goes into 28 evenly, so that equals 1. 71 divided by 4, 0.75, that's the same as I to the cubed, or -I. Here we get a remainder of 2, 0.5, that's a remainder of 2, so -1. 117, again, a remainder of 0.25, so just like this one, anytime you get 0.25, your answer is I. Here again, we've got one that divides evenly by 4, so that's going to equal 1. And that was our last one here on this slide. But again, when you get these big numbers, divide by 4, your decimal here will dictate or tell you where you're at. When in doubt, go back to this slide right here to help you out. Alright, these are a little different because now we've got negative numbers. And what we want to do here, what you'll see, is I'm going to take a multiple of 4 and add a positive number to that to get back to negative 15. So I think we'll all agree that negative 16 plus 1 equals negative 15. And so I can actually write this as I to the negative 16 times I to the first. Why can I do that? Because when you multiply two numbers of the same base, you add the exponents. So negative 16 plus 1 gets us back to negative 15. Again, I want to use a multiple of 4. Why do I want to do that? Well, I to this negative 16th is really I to the 4th to the negative 4th. I to the 4th is 1. 1 to any power is 1. And so 1 times I will be just I. Same idea here, negative 30. So if I take negative 32 plus 2, that adds up to negative 30. This is a multiple of 4, so that's really I to the 4th to the negative 8th power. I to the 4th is always 1. 1 to any power is 1. And so we really have I squared, or 1 times I squared, which is negative 1. Okay, complex numbers are a combination of real and imaginary. So they are in this form right here, a plus bi. And so you see all these examples here, 2 plus 5i, 16 minus 2i, or we could say 16 plus negative 2i. That's a complex number. We could put a 0 here. So saying 13 plus 0i, that's the same as 13. And so these are all in complex form. A pure imaginary number is when we don't have the real number here. So you can see all of these just have I with no real number in front. We always write these with the real number, if we have one, we always write the real number in front. So we would never say 5i plus 2, we would always write it as 2 plus 5i. Similarly here, we would always write that as 16 minus 2i. Just like any other variable, we can add and subtract these. So I'll start on the left side here, and we'll combine our real numbers. So 5 plus negative 2 is going to be 3. And negative 3i plus 4i will be 1i. Now you don't have to reorganize these in order. I just did that so you can see we combined the real numbers and the imaginaries to get to our a plus bi form. So same idea here, 10 minus 24 and negative 2i minus negative 11i. Remember, if you minus a negative, you're really adding. Again, you don't have to put them in this order. I just do that so you can see the real numbers with real numbers and complex with complex. And that's going to be negative 14 plus 9i. Again, always put this real number first. We can FOIL these. No different than you would if it was a variable as a or x or t or any other variable. The one change comes at the very end, and we'll see that when we get I squareds. So if I FOIL this out, first, outside, inside, last, I'm going to get right here. And it's this last term is where we got to be careful because we know I squared is negative 1. So this is really 12 times negative 1, making this last term negative 12. So I really have 35 minus 12, or 23, and I can add my middle terms, they're like terms, for 44i. Same idea here, I'll FOIL, so I'm going to get 14 plus 35i minus 6i minus 15i squared. Again, I got to take care of this, so negative 15 times negative 1 is plus 15, giving me 29 plus 29i. All right, one last one. I did this on purpose here. These are conjugates or opposites. So you got a plus bi, a minus bi, kind of like 3x minus 4, 3x plus 4, where the middle terms will cancel out. Same idea here. So you can see the middle terms are opposites. They're going to cancel. Negative 49i squared is really positive 49. So this is going to simplify to 149. Our bottom example here, same idea. So you can see that we have conjugates here. So our middle terms cancel out. I didn't even write them. You can if you'd like, but I didn't even write the middle terms because we know they cancel out. So negative 289 times negative 1 is positive 289 for a total of 458. All right, last slide for today. I was going to deal with conjugates. And conjugates, when we deal with this, we've got to rationalize this complex number. Just like we can't have square roots in the denominator. If you remember earlier in the year, we had conjugates with square roots. That's why I have this here. So we had to multiply the top and bottom by square root of 2. And then we can get a rational number here on the bottom and simplify this. We've got to do the same thing here. I can't have an imaginary number in the denominator. So my conjugate of this is the opposite of that. So instead of 1 minus 2i, we change the value of the second term, so 1 plus 2i. So the first number here stays the same, still ones. We change the sign of the I term, and that's a conjugate. Now I can FOIL top and bottom. And so when I do that, let me just slide this down here for a second. When I FOIL the top, I get here. I'm going to simplify this negative 14i squared. It's really plus 14, so 8 plus 14 is 22. Combine my I terms for 9i. Do the same thing on the bottom. I end up with the middle terms are going to cancel out, so I didn't even write them down here. Negative 4i squared is plus 4, so 1 plus 4 is 5, and that is my answer. Now, if these were both divisible by 5, we'd simplify. So, for example, if this was 25 plus 10i, then we would divide both of them by 5 and simplify. But since we can't do that, this is our final answer, and that's in rational terms. And that will wrap up our notes for today in regards to complex numbers. So if you got any questions, shoot me an email, let me know. We'll do a live chat as well. Make sure you check the weekly rundown PDF and weekly video for that. There's 2 live sessions this week for help, and we'll go from there. All right, take care. Welcome back.